On the night of August 15, 1977, while most of America was sleeping, an automated radio telescope in Delaware, Ohio quietly recorded the most important 72 seconds in the history of the search for extraterrestrial intelligence. The telescope was called Big Ear. It belonged to Ohio State University. It had been listening to the same patch of sky in the constellation Sagittarius, night after night, for years. That night, something arrived. A narrowband radio signal at exactly 1420.456 MHz. The signal was 30 times stronger than the background noise. It rose, peaked, and faded over 72 seconds, exactly the time it should take for a fixed object in space to drift through the telescope's field of view. 3 days later, an astronomer named Jerry Yemen printed the data. He saw a column of letters and numbers that should have been all zeros and ones, then suddenly read 6UQ1. He took a red pen and circled it. In the margin he wrote a single word. Wow. The wow signal was never detected again. 48 years and dozens of follow-up campaigns later, we still cannot explain what produced it. This is the closest thing we have ever found to a signal from an alien civilization. The Big Ear telescope was a strange machine. It was not a dish. It was a flat field roughly the size of 3 football fields with 2 metal mesh structures, one curved and one flat, that reflected radio waves from the sky into a series of receivers. It looked like a giant outdoor microwave oven. It could not be steered. It pointed straight up, and the rotation of the Earth swept its field of view across the sky. Ohio State had been operating it since 1963. Starting in 1973, they dedicated it to the search for extraterrestrial intelligence. It was the longest-running and most thorough SETI program ever conducted. Big Ear listened in 2 beams, side by side, separated by about 3 minutes of sky drift. The data was logged on continuous feed paper as columns of letters and numbers, where each character represented the strength of the signal at that frequency in that beam during a 10-second window. Most of the time the columns were full of zeros and ones, indicating background noise. The system was set up so that any signal stronger than 9 on the logarithmic scale would print as a letter. 6UQ1 represented a sequence of strengths starting at 6, peaking at 27, then dropping back. 27 was off the chart. The frequency was profoundly important. 1420.4 MHz is the natural radio frequency emitted by neutral hydrogen, the most abundant element in the universe. SETI researchers had argued for years that any civilization trying to communicate across interstellar distances would choose this frequency. It is universally recognizable. It is in a quiet part of the radio spectrum. It is the obvious place to broadcast or to listen. The WOW signal arrived on the watering hole frequency, exactly where every theoretical model said it should arrive. The signal did not pulse, modulate, or contain any obvious encoded information. It was, as far as anyone could tell, a continuous narrowband carrier. But the rise and fall over 72 seconds matched perfectly the expected behavior of a signal from a fixed point in space, not a sweeping satellite or moving aircraft. Earthly interference was ruled out within hours. Aircraft do not stay in one position for that long. Satellites broadcast on different frequencies. The frequency itself, the International Hydrogen Line, is internationally protected from terrestrial transmissions. So whatever produced it was almost certainly somewhere out beyond the atmosphere. Ohio State immediately reoriented Big Ear and listened to the same patch of sky again. Nothing. They listened the next night. Nothing. They listened for the following month. Nothing. Other telescopes around the world joined the search. The Very Large Array in New Mexico, the Allen Telescope Array, the Green Bank Observatory, all conducted follow-up searches over the following decades. Not a peep. The signal was a single, isolated event. So what was it? Theory 1 is the comet hypothesis. In 2017, Antonio Paris, a planetarium professor at St. Petersburg College in Florida, proposed that 2 comets, designated 266 P-Christensen and P-2008Y2, may have been passing through Big Ear's field of view at the right time. Comets carry hydrogen clouds. Theoretically, a hydrogen cloud could emit a signal at exactly the right frequency. Paris published his theory in a peer-reviewed journal. The astronomy community did not buy it. Critics, including the original Big Ear team, pointed out that comet hydrogen clouds are diffuse and slow-moving, not capable of